Good day everyone, I am Ronald Embricones from Bisat 3 English A, and for today, we will explore how we can determine the position of a certain value compared to the other data set. It is something we often see in test scores and rankings. But before that, let us first know our learning objectives. At the end of the video lesson, the learners are expected to do the following with at least 75% proficiency level. Number 1. Define quartiles, deciles, and percentiles. Number 2. Interpret measures of relative positions such as quartiles, deciles, and the percentiles. Since we already know our learning objectives, what do we mean by measures of relative position? Measures of relative position are conversions of values, usually standardized test scores, to show where a grade value stands in relation to other values of the same grouping. These are the statistical tools that help us see where a particular value stands compared to the rest of the data. For example, when you see your exam score and wonder, did I do better or worse than most of my classmates? That's where measures of relative positions come in. They help us to compare one score to the group. One of the most common ways to measure relative position is through the z-score. The z-score for a given data value x is the number of standard deviations that x is above or below the mean of the data. The z-scores tells us how far a value is from the mean, measured in standard deviations. So in simple terms, it tells us if a score is above or below average, and by how much. The formula is z-score value is equal to the data value minus the sample mean and divided by the standard deviation. So here's the example. Raul has taken 2 tests in his chemistry class. He scored 72 on his first test, for which mean of all scores was 65 and the standard deviation was 8. He received a 60 on a second test, for which the mean of all score was 45 and the standard deviation was 12. In comparison to the other students, did Raul do better on the first test or the second test? From the given situation, the data value was 72 minus the mean, which was the 65, divided by the standard deviation 8. 72 minus 65 is equal to 7, and 7 divided by 8 is equal to 0.875. So the z-score of Raul in his first test is 0.875. While on his second test, the data value was 60 minus the mean, which is the 45, and divided by the standard deviation 12 is equal to 1.25. So the z-score of Raul from his second test is 1.25. Based from the result, Raul scored 0.875 standard deviation above the mean on the first test and 1.25 standard deviation above the mean on the second test. These scores indicate that, in comparison to his classmates, Raul scored better on the second test than he did on the first test. And that's how we compute for the z-score of a given data. Aside from the z-score, we also have the quartile, decile, and the percentile. A quartile divides a set of data into 4 equal parts, and each part represents 25% of the entire data distribution. It helps to identify how the values are spread out and where the middle points of the data lie. While the decile divides a set of data into 10 equal parts, and each part represents the 10% of the data values. It provides a more detailed way to analyze the distribution and compare data positions. While the percentile divides a set of data into 100 equal parts, and each percentile shows the percentage of data values that fall below a specific value. It is often used to rank scores or performances such as in tests or assessments. Quartile, these are the numbers quartile 1, quartile 2, and quartile 3 that partition a ranked dataset into 4 equal groups. Here's an example of a quartile. Find the first, second, and third quartiles in the given set of data. We have 45, 46, 48, 51, 53, 54,